Assalamualaikum warahmatullahi wabarakatuh. This is just a quick video to talk about the 4 types of measurement scales, and they are important because they kind of help us to choose the right statistical method in data analysis. The first scale is nominal scale, and this is the weakest of all because our data here is recorded in the basis of a name. For example, what is the gender of newborn infants? And imagine giving this question out to people, and the answer that you will get back, the sort of data that you will get back, is going to look like this. Female, male, male, female, 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 male, female, male, and so on. So this is how your data set is going to look like, and clearly this is not in numbers but in the basis of a name. Yeah. The next example here is what's the diagnosis given to patients in the psychiatric hospital. Now, the patient can be manic depressive or schizophrenic, and this is another example where you are going to have a data set in terms of basis of a name again. This data set here can actually be properly organized if you create a table that contains 2 columns, for example. And here we're going to list the gender accordingly. We have female and male, and frequency is basically you have to count how many females do you have and how many males do you have. And because of that, this sort of nominal data is also called count data. Okay, you just counted just now, and also categorical data or frequency data. Okay. Next is the ordinal measurement scale, which makes it possible to rank the subjects. In this case, you are able to see some sort of order in your data set, even though your data set is actually looks like in the basis of a name, but that basis has some sort of order to it. For example, least beautiful to most beautiful, or strongly disagree to an opinion to strongly agree to a particular opinion, let's say, or least severe pain to most severe pain. And these are examples, okay, not limited to this one, but these are examples of ordinal measurement scale. So here, the difference between ranking is not necessarily equal. I'm going to give an example to this. Let's say you go to observe the sports day, and then you see the first person completed the race, and that person will be ranked as number 1, right? And let's say that this person completed the race within 2 minutes. The next time you observe the next person that completed the race, and that person will be ranked as number 2, and this person, let's say, completed the race within 3 minutes. The next person that completed the race will be ranked as number 3, and let's say that this person completed the race within 9 minutes. So you can see that in terms of ranking 1, 2, and 3, and so on, the difference between the ranking is not necessarily equal. For example, the differences between the first and second ranking is 1 minute apart, but if you look at the differences between ranking number 2 and 3, it is 6 minutes apart. Yeah. Right, next is the rank data also does not tell the magnitude of the differences. As an example, let's say we talk about patient's level of pain. Let's say you ask a patient to rate their level of pain, and there are several categories. For example, we have mild, moderate, maybe excuse me, severe, very severe pain. So these categories here are example of some sort of ranking, even though the answer that will be given by the patients are in terms of names. Okay, you can call it names, but the names here are in a particular order. They are arranged in a particular order, ordinal. Yeah, so there the order here is from mild to very severe. There is a clear order or a clear direction to where it is heading. However, even though there is some sort of order, but the rank data, it doesn't tell you the magnitude of the differences. We don't know how far is the differences between mild and moderate, or is it similar to severe and very severe? How far are they in terms of magnitude of the differences? We can't tell that. Okay. Sometimes the researcher also kind of assign numbers to all these category. For example, this is category 1, 2, 3, and 4. Even though it looks numerical, but uh, it doesn't mean that the differences between this category is one. You see, because numerical assignment is just to make the whole questionnaire or survey simplified. Okay, right. Next is the next one is interval scale, and this scale makes it possible to be ranked. That means we have some sort of order that you see in ordinal scale, but that the difference is, or the additional characteristic to it is that differences between measurements have meanings, and it has a 0 point. It is arbitrary in this case that it has a 0 point, although it has a 0 point, but the point 0 here is not a true zero value. So in other words, there is no fixed beginning to this type of data that we have. For example, measurement of temperature in Fahrenheit or Celsius. This is the classic examples of interval scale. Okay, so what it means by that is when you say that the temperature is 0 degrees Celsius, 0 degrees here doesn't mean that there is no temperature. 0 doesn't mean there is no temperature. So this is what it means by it has a 0 point, but no true zero value in that case. So similarly to temperature measured in Fahrenheit, when you have 0 value in Fahrenheit, it doesn't mean there is no temperature. Okay. Other examples of interval scales include, let's say, IQ result, also grade levels in school. Okay, the next type of measurement scale is ratio scale, where the difference between this scale with the previous one is it has a true 0 point. When it has a true 0 point, it means you have the complete absence of the trait being measured. For example, height and weight. When you have 0 centimeter height, it means there is nothing there, right? So that is the meaning of it. When you have 0 kilogram, that means it's really nothing there. No, nothing. Okay. And this is an example of a ratio measurement, and Another example, if you want to compare with what you have seen over here for the interval measurement scale, this if you, let's say you measure the temperature in Kelvin. So this is an example of ratio measurement, because when you have 0K, this totally indicate that there is the absence of temperature, really. Okay, so that's it. Okay, so because of that, well, not because of that really, but I'm just going to talk about the characteristics of ratio measurement scale. The difference between measurements have meanings. What it means by that, let's say we have a person that is 70 kilogram and another person that is 50 kilogram. Therefore, a person that is 70 kilogram here with a weight of 70 kilogram definitely is heavier, definitely is 20 kilogram heavier than this person at the weight of 50 kilogram. So that's what it means here. It have meanings. Similarly, we can make a ratio interpretation. For example, a person weighs at 100 kilogram is twice as much as a 50 kilogram. So ratios measurement is I think the most interesting, because you can do all sorts of data analysis with this type of measurement, and this is the weakest of them all, because it's just related to the basis of a name, and not much that can be done with this. Okay, all right, I think that's all for now. Thank you very much for watching.